Hi, good afternoon, everybody. My name is Craig Taylor. I'm an architect on the Xbox Services team, and I'm here to talk about how we use .NET Aspire to boost our productivity. So the first thing I want to do is go over a little bit about our Xbox services. I have an example service that we're going to Aspirify, and then we're going to go through a live demo using Visual Studio. We're going to streamline our orchestration locally so we can get up and running fast. We're going to integrate with Azure. We use a lot of different Azure services, and so we want to do that locally as much as we can. And then finally, we're going to instrument all of our code so that we can view it in the beautiful .NET Aspire dashboard and be able to verify all that stuff locally. So let's get into it. So the first thing I want to talk about is the scale, or the scenarios of our service. We power the login and social scenarios. So think when you boot up your Xbox and you log in, you get your login token, you're sending messages to your friends, you're seeing who's online. We see millions of concurrent users, and we have very widely experiences based on like the calling patterns. So like when you boot up your Call of Duty game is going to have a very different calling pattern than your Fortnite, and people go back and forth between those games, and we see a lot of high load. So our architecture is microservice based. We run on Azure Compute, and we deeply integrate with Azure services, especially Event Hub, Cosmos DB, Blob Storage. We use the latest versions of C#. We use REST APIs and ASP.NET to run our microservices, and we use 𝗦𝗲𝗀𝗀𝗶cie for our telemetry. So now I'm going to talk about the example service and how we're going to bootstrap .NET Aspire for that. So here's our example service. This is a common pattern that we have over at Xbox. We have an event hub that receives events from other gaming services. Our worker service is going to process those events and send them to a Cosmos DB. Then we have an API service, which is our REST-based layer. It's going to call out to the Cosmos DB from a game client, and then maybe we'll do some calls to some other services, do some joins, whatever we need to do, and then return that as a JSON payload back to the game client. So that's the example service that we're going to be working with. So the pain points that we had before .NET Aspire was you'd have to have a bunch of complex startup scripts, maybe some PowerShell, a little bit disconnected from your C# environment. You have to manually configure things, start up emulators, things are going to start up at different times. And then finally, it's kind of a pain to see the full breadth of telemetry. If you're using 𝗦𝗀𝗀𝗀 and you're using traces and logs and metrics, it's hard to see all of that and really get a clear picture. We've been doing a lot of like console write lines and that kind of stuff, maybe bespoke custom tooling to be able to see that locally when we're running locally. And .NET Aspire really helps to make that pop. So with that, we're going to head over. We're going to do 3 things with our demo. We're going to orchestrate our services, integrate with Azure, and then we're going to instrument our code. So I'm going to pop out of my PowerPoint here, and we're going to look at Visual Studio. So this is the API, the example service. Here's the API REST-based service. Here's the worker service over here. And then we have a test producer worker, which is going to function as another gaming service pumping events to this test service so we can have some data to play with locally. So the first thing I want to do is I want to add my .NET Aspire app host. So I'm going to go add new project. We have a .NET Aspire app host over here. I'm going to go next, and I'm going to give it a name, example.app host. And we want the latest version of .NET 9. So now we have an app host here, and this is a new type of project. It has a little fancy new .NET Aspire icon. We're going to go into the program.cs and see that it's not doing too much right now. So we got to give some references to our other services. I'm going to give a reference from my API service to the app host, test producer, and then the worker service. So now app host can now look into those other services as project reference. I'm going to bring in some code here to help bootstrap our services, get them orchestrated. So I'm going to copy paste this in. What this is going to do is basically create an API service, a worker service, and a test producer service with those references. And instead of running each of those services individually, I can now right-click on my app host and say set as startup project. And now I can basically hit F5. And what this is going to do is it's going to build the app host and get everything orchestrated for me in a very consistent way. And then give me a beautiful UI, which is going to show me a little bit about the resource, the status of the resource, the different settings that I have for the resource, look at the console logs, and we'll dive into the telemetry at the last part of the demo. But we're going to wait for this to bootstrap up. And this is the other way you do it, with your PowerShell scripts is you have to run these individually, or maybe you have different instances of Visual Studio. A little bit more complicated. So with this, now we have all 3 of our services running. We have the endpoint to our service that if I clicked on it would error out because we don't have any Azure integration yet. But you can click on our API service, and then you can go and say, what are the different values you have for your environment variables and settings? So you have a nice view, and just that alone is pretty cool because you can, just have a bootstrap of just like clone this and hit F5 and you get everything orchestrated. But the next step is that we want to be able to have our Azure integration, right? We want to be able to talk to a real Cosmos event, a Cosmos DB and a real event hub to be able to do events and be able to see all this stuff interact together locally. So I'm going to close out of this. And we're going to hit the stop button there. And then we're going to bring in the next layer of code. So there's a couple project references I'm going to bring over. These project references are going to give me all the emulator support that I need via .NET Aspire. So bring these packages in here. Save it. And this is just, your Cosmos DB, your event hubs, and just your Azure storage and event hubs, all these different things that are going to allow us to have our services interact. So now I'm going to bring in the new orchestration code into my program.cs for the app host. Paste that in. Go over this really quick. So what this is going to do is it's going to add your Azure storage emulator, give it a specific account name, add your Cosmos DB, add your event hub, do all that setup stuff that you would normally have to do anyways, often very manual or very prescriptive. This is all like in a C# file. It's very familiar and it's right next to everything. Then also you give references to the other services. So here's your API REST-based service. This relies on Cosmos. So you say, give it a reference to Cosmos and then also wait for Cosmos to start up. Worker service cares about Cosmos. It cares about Azure storage, event hub. So it gets references to all those and waits for those to start up. And then finally, the test producer worker, it only cares about Event Hub. Give it that reference and say, wait for Event Hub to start up. So now while that's running in the background here, you see that it's gotten brought up. One of the cool features I'm going to show really quick back at this is you could say persistent lifetime, which means your emulator is going to continue to run in the background. It won't have to bootstrap itself. So you can have rapid iteration. You can stop, start, and your emulator will just continue in the background. So that's why everything is started up so fast. So I can minimize these. And you can see that they're all running. You can go to your console output really quickly and see, here's my worker service. It's receiving a bunch of trace events, showing that it's processing some of the data that's going on here. So the next thing I want to, I don't want to be remiss. I don't want to miss clicking on my endpoint and having this actually flow from our REST-based service to Cosmos DB and get you back JSON to kind of prove out that we're really pumping data and then we're actually sending a JSON payload back to the user. So with that, I'm going to stop here, and then I'm going to bring in some telemetry. So it's nice to be able to have all the stuff locally and be able to iterate on the telemetry as well. So what I'm going to do is I'm going to add a new file here, which is going to give me ability to add metrics. So I'm going to go add new thing, go API service metrics. And then I have a new file I'm going to bring over for my last part of the demo here. So this is the API service metrics. We're using OTel and we're using the native .NET patterns. So we have an iMeter factory that we get injected. We create the meter, we create our counters. And in this case, we're creating two different counters. We have an API request, which is just going to be every time the controller gets called, we're going to tick this. And then we have a duration, which is going to be handled by a stopwatch to basically say, here's how long this thing took. So now we got to wire it into our controller. So we're going to go into the controller that's handling the events requests, scroll up to the top, and I'm going to add a new parameter here. So here's the new class that we just created. Get that sent in, make sure to save it off so I can tick those counters later here. And now I'm going to go to the end of my API controller. So in this finally statement, I'm going to tick the request and say, what kind of status code it got. It's a GET call, and here's the API that got called. Then I'm going to also uncomment this one, which is just going to have a stopwatch telling me how long that this took. Now I need to go in and use DI to basically create this so it can get injected into my controller class. So with that, now I can hit start again. All the telemetry will be wired in there, and we're going to look at that here in a second. Wait for the dashboard to get fired up here. Here's the dashboard. So as you can see, all the emulators, everything started up super fast. So you can hit the ground running with everything. So now I can hit this API over here. Everything comes back. And then I can go to these tabs that I haven't shown you yet. Here's the metrics tab. Here's your API service and all the different workers that we have going. And now we have API request duration. So if I go over here, and you'll see that it's real time too. So if you go over here and hit F5 a bunch of times, you'll see it immediately go up and tick. You get your duration counter that I had with your exemplars and all the different features that OTel has locally on your dashboards here. Before you get to production, you can verify all that stuff. You can go over to the other workers that I have. Here's one that's receiving events from Event Hub, the regular cadence of the test producer that's pumping events. It's getting the events and then it's flowing them over to Cosmos DB. And then it's doing the blob checkpoint operations as well to, be able to start up and shut down and all that to know where it can checkpoint for the next time. Be able to exercise all that locally. The traces are really powerful too. You can see all the different distributed tracing going on here. And the really cool thing is if you go to, for example, the test producer worker, you'll see how that flows through. So you fire an event from the test producer worker, then that flows to the worker service, and you're able to see all of that telemetry, all that OTel distributed tracing telemetry, all on this one panel here, flowing end to end, which would be really hard to visualize and verify if you're doing something like this without this kind of tooling. And you can go and click on here and see all the different details, go view logs, see all the structured logs that are associated with that distributed trace as well. And yep, all your console logs are here, all your distributed tracing, metrics, everything. So with that, I'm done with the demo. I want to say that this is kind of the solution where you can get to, with like a README file with someone who's new and onboarding to your team, you can say, just go to this service, just clone it, and then start app host, and that's all you need to do. So it's clone and F5, you get all your integration locally. And that's my demo. Thank you.